I'm here to ask the question and wonder, I guess, if we can be a little bit nostalgic about technique. For this occasion, I'm prompted to go back to some field work I did on case modding from 2004 to 2006. It's a return informed by conversations with Darren on retro console modding, some work that Darren and I are doing on materiality and code in Minecraft, and a new project I'm starting on maker culture. Case modding is the DIY practice of modifying or altering both the enclosures and components of any consumer electronics, but mostly this refers to PC computer systems. The practice flourished in the mid-90s through the early 2000s with the convergence of custom-built PC systems using highly configurable Pentium 2 and 3 chipsets, the rising popularity of PC enthusiast culture coupled with the decreasing cost of components, including cloned chipsets. And in my story, the rise of multiplayer Twitch shooter games like Quake from 1996 and Counter-Strike from 2000 are also crucial, as is community-based LAN parties where gamers would gather to play these games in relatively lagless, hardwired LAN arrangements. LAN parties, in particular, became the stage through which gamers came to perform their case-modded machines in competitive and cooperative displays that were as much about the hardware as they were about any kind of virtual prowess. Today, the small community-oriented LAN parties have given way to larger digital festivals like DreamHack, which combine traditional LAN gaming competitions with esports, Consumer Electronics Expo, and often live music and dancing. Case modding at these events has been formalized into modding competitions and exhibitions with corporate sponsors, or else sidelined, especially as many early modding practices such as case windows and cold cathode and LED lit components become commercially standard for almost all gaming PCs. This is also arguably a form of case modding. Anybody know what that is? Bitcoin mining. So, with a sad shake of the head, do like nostalgic shake of the head, whatever, I'll let nostalgia do its thing and then try to return to the present for the sake of opening up discussion. In 2004, I was studying massively multiplayer online games like EverQuest and World of Warcraft. And I saw LAN parties then as a kind of material inversion of the MMOG. My field site was LAN ETS, which was a gymnasium-sized LAN party hosted yearly at an engineering school in Montreal. It was easy to read the intense proximity of gamer bodies, 100 or so mostly young white and Asian men together for 72 hours, as the antithesis of the isolation of the MMOG gamer with their online pseudo-societies. Now, as nostalgic luck would have it, I still have the image that launched my project on case modding. Couldn't believe I found this. I remember this perfectly, even though my picture here isn't that great. This was a young Asian Canadian guy, an absolutely brilliant player with an extremely performative play style in that he was dressed always totally in black and barely moved a muscle while he played. Here, the man is juxtaposed with his intentionally oversized computer, a very subtle case mod of all black with LED highlighting. And this would now be a standard look, except for the size. So a lot of people looking at it now is like, what's the big deal? But this is unusual for the time. Solid and stoic. We know that this is performance because everyone has to bring their own computers to the LAN party. And competition gamers want high-performance systems in very small and light cases, also known as LAN boxes. The gamer was a case modder. He was messing with hardware, aesthetics, game culture, and Asian Quebec masculine identity all at the same time. So that guy opened my eyes, and then all I ever saw were the machines. The story is told differently amongst case modders, but in general there are two trajectories of practice that are clustered around modifying, building, and displaying computer cases on the one hand, and creating custom cooling systems for overclocked CPU and GPU chips on the other. The builds along both trajectories can become excessively elaborate, but their origin remains the same in that the motive to Dremel cut a hole in a standard beige box IBM PC case both changes the aesthetics and provides airflow for cooling. Even today, many case modders insist on the functional aspect of what might otherwise be seen as a form of vanity display. It is a mark of pride and honor to play Quake on a custom modded rig that demonstrated performance at low cost. Gamers who bought high-priced custom or off-the-shelf systems, like LAN boxes, were frowned upon. The Dremel cut is the quintessential basic modding skill. As one modder told me, you can't be afraid to break the skin. An apt metaphor, since unlike the mere painting or vinyl stickers that you could put on these cases, the Dremel cut is first and foremost an act of anti-corporate appropriation and individuation, which reinforces at least what used to be the warranty-voiding practices of overclocking the processor. For the consummate modder, this courage to break the skin and delve into the guts of the machine had to extend all the way to the most risky but rewarding proposition of overclocking the processor. But the modding was not in overclocking, which is actually not that hard to do. It is so much as it is in voltage regulation and cooling. Case modders become local experts in thermodynamics using heat sinks, gels, fans, liquid cooling systems, all on display through Dremel cut windows and highlighted with cold cathode tubing, which is a crossover from car hot rodding and LEDs. Case modders valued both performance. They always quote all their system specs, and especially their CPU clock times and system temperatures, as well as display. And attention to orderly wiring and tubing, lighting and color, the external look and feel. Mods which focused on display only were criticized or relegated to a category of pop art, and mods which hid the components or disguised the computer as other objects were also not kosher. It was crucial to not only do the mod, but also be able to show and demonstrate your work, to actually play the machine and not just look at it. Online case modding sites are full of video, pictures, and walkthroughs, videos, pictures, and walkthroughs, and a prelude to the kind of how-to videos that now litter YouTube. So let's cut a wee bit deeper. As a matter of function combined with fiction, Twitch gaming at LAN parties is about speed at cost. The faster the CPU, the GPU, as in the more operations per unit time, the better and more reactive the gamer can be. But skill is dependent upon achieving this at the lowest possible cost. You can't just go out and buy a fast computer. You have to demonstrate that you've done it at the lowest possible cost. The analogy of the relationship of car mechanics to car racing is totally appropriate here, but the point of LAN parties is generally for the machine to disappear. Near zero lag, good enough computers, and so on, so that human skill can be visible and measurable. And this is a key issue in esports, because if the machine is too prominent, then is the player any good at all? This meant that the absolute speed of the processor begins to lose meaning in a Twitch match past a certain point. The cultural solution to this was to decouple CPU speed from the game performance by literally drag racing the CPU instead of playing games. That way, the case modders could have their cake and eat it too. Head-to-head, the CPUs are overclocked in increments and measured using custom racing software. This is called competitive overclocking. Races can be absolutely spectacular with nasty-smelling meltdowns, mini-fires on the one hand, and this sort of alien light of fluorescent liquid cooling, and most recently the puff of smoky liquid nitrogen on the other. The system is performing, the modder is the engineer. None of it matters anymore for actually playing and winning games, but it tells us everything about the socio-material assemblages of game culture. In 2004, CPU racing was more or less spontaneous and organic at the LAN. Today, they look like this. And the story of sponsorship by chip makers, Intel and AMD, is a great one, because now overclocking is sponsored by the chip makers, and they're these incredible affairs, usually featuring liquid nitrogen, which always is very spectacular. One important technique of the performance case modder is called chip lapping. Now, the idea in chip lapping is to use various abrasives on the lid of the CPU, GPU chip to maximize molecular level surface area contact between the chip and a heatsink. It matters how you sand the chip, how you protect the pins, how you measure the performance difference. And once again, we see function and display. And once again, we see function and display as the pseudo-engineering of the chips gives way to the ultimate mirror finish, because every account always finishes with this beautiful shot of your beautiful chip. I also continue to be fascinated by the role of touch in lapping. It's connected with this idea of overcoming fear, to touch the CPU, to feel its smoothness. In fact, that's probably one of the only ways the best judge of smoothness. They don't really have instruments to measure it. The CPU is not so much the brain of the computer as the heart. If you fuck it up, you just lost 50% of the cost of your system. Lapping is the heart surgery of the case modding world, and yet it is not surgery because anyone can learn how to do it. And that is the point of modding technique. It is utterly mundane and hyper-specialized work all at the same time. So here we are. Case modding is mundane science, perhaps? The expertise acquired and lauded here pertains to a relationship with the computer system itself. It's wrong to think about this as a matter of control or power, since concepts of care and intimacy are equally applicable. And I have just enough time now to lay down 3 tracks we might pursue from here by way of discussion. I'm still wrestling with this first one. Almost all case modding occurs in a relationship to an industry standard or threshold. It could be that bland beige box of the IBM PC that needs to be cut into shape, or it could be the clock speed on a Pentium 2 set to a performance standard for running Microsoft Office, as business use was the main market driver for PCs right through the 2000s. It's not any longer. Modding is a cultural response to standards. In my story, for gamers seeking the performance of speed at cost. But while the industry engineers actually designed chips and motherboards so that overclocking was possible, they didn't spec for it until later when modders became customers. And that meant that modders were doing a kind of reverse engineering with their own cobbled together techniques, languages, and performances. And this is actually a really important part of the story. Chips were overclockable in the 2000s because of fluctuations in the market. So what you would do is print a whole bunch of boards, but have them be configurable depending on what clock speed would sell the best. And so that's why you have overclockable boards at that time. With the same board, makers could set the clock at whatever made the most economic sense. There's also what is called the silicon lottery, in that not every silicon wafer had the same performance. You couldn't actually get exact same performance out of every chip. The dance between industry standards and modders is really important. It's a kind of zone of indeterminacy that helps draw a cultural technique together, even if it's only temporary. My second point is that case modding bears all the traces of how we come to understand expertise in relationship to cultural and social differentiation. This is classic science and technology studies stuff, and it's easy to trace the constitution of expertise in case modding as being tied to social organization, inclusion, and exclusion. But I think what is most intriguing to me about this is how the machine remains an importantly aesthetic object, and this has curious implications for thinking through the gendered and race composition of most modding communities. In writing I've done before, and I want to return to again, I refer to this as the construction of virtuosity rather than expertise. But I think there's more to be pondered with this idea of the beautiful performative machine, especially when we were talking about nostalgia and retromod coming up next. Finally, there is a point about the sensual mechanics of modding. The touching, cutting, pulling, fitting, viewing, and even smelling of a material assemblage, the primary purpose of which is its erasure in ideologies of the virtual. Of course, we know this already as current commercial VR headsets give truth to the lie once again, but modders consume this ideology differently because they are in touch with their machines. There's actually great work by Antoine Henyon on amateur rock climbers and wine drinkers on the importance of material intimacy and this role of touch in composing their practice. In the absence of authorized expert knowledge, we return to the world through a kind of collective interaction and the recomposition of assemblages. In this space, my nostalgia decrees that new and better compositions of the world are possible through modding. Sound good? That's good. Good.
Hi, okay. So, So if you told me 2 years ago, when I started the Residual Media Depot, that in order to talk credibly about video console modding cultures, I'd have to learn RGB signal processing, up to and including messing around with multimeters and oscilloscopes, and that I'd have to relearn skills that I haven't used since the 8th grade, like reading color bands on axial resistors, sketching circuit diagrams, and soldering, I would have told you that you're barking mad. Such operations are simply outside of the professional formation of a humanities academic, even one that professes to work in the field of material media history. When we learn such skills, we learn them backwards as amateurs, in both the classical and pejorative sense of the term, I think. As a methodology, close reading has a lot to answer for, because it has created entire generations of academics for whom material technology is merely a set of convenient themes for theorization. What I'm after, on a theoretical and methodological level, is a rapprochement between ostensible opposites: Ernstian media archaeology and Birmingham cultural studies. We might call that rapprochement something like cultural technique. Siegfried Zielinski might call it a philology as exact as possible of non-perfect, precise things. But in the interest of providing some redress for decades of front-loaded hermeneutics, I'm going to tell you what I've been up to for the past few months and keep the theorizing to trace amounts until the very end. So I've been working with a series of Nintendo Super Famicom consoles, including its North American variants, the Super Nintendo Entertainment System, and its final version, the new style Super NES. Each of the consoles that I've been working with has been physically modified to alter its video output capabilities, and it's taken a lot of forensic work for me to learn exactly how. I want to understand this console's residual afterlife, because 27 years after its first appearance, it refuses to vanish. In fact, it's deeply imbricated in several overlapping global economies based around bricolage, micro-manufacturing, collecting, reuse, and nostalgic recommodification, all of which unfold after the console's life cycle as a consumer commodity. These networks are my ultimate research object, but you have to start somewhere. So let's start with something familiar. The socket on the back of many Nintendo consoles is called a multi-out. And on the original consoles in the Super Famicom family, it supports 3 types of video signals: composite video, S-video, and RGB. Most people who have owned these machines only ever used composite connections, these things. The yellow RCA plug transmits all of the elements of the video image in one signal, but on different frequencies, hence composite. About all you can say for the quality of a composite signal is that it's better than the older RF standard. Nevertheless, composite compression necessarily dulls the image. S-video is a slight improvement because it maintains 2 signals, one for the information about brightness, which we call luma, or Y, and one with the color information, which is chroma, or C. So an S-video plug has 2 pins for these channels, 2 more pins, and 2 more pins to ground them. S-video had 4 or 5 times the horizontal resolution of a VCR, but only about half of a DVD player, so it began to show its age quickly in the digital era. RGB is where things get interesting because, along with its accompanying synchronization information, or sync, it's the form in which the image is created or captured and the highest quality analog signal. In North America, most TVs never had a physical video connector that could carry an unaltered RGB signal. In Europe, they had SCART cables, and in Japan, a differently wired version of the same hardware called JP21. Console modders use the now obsolete SCART standard to convey RGB signals from their consoles to their monitors, whether CRT or flat screen. I'm not going to talk about component mods today, mostly because I just published a forensic teardown of a component modded Super Famicom in the Zielinski issue of Whitney Tretchen's Thresholds blog. So, on with the other stuff then. The 3 final versions of Super Famicom and NES, called One Chip 01, One Chip 02, and One Chip 03, are the most highly coveted because they not only output RGB, they combine the original console's 2 separate video chips into a single superior chip, the SCPUN. Even on these machines, though, players will complain that the image is sometimes too bright or that there are ringing or ghosting effects. What modders do to correct this can range from simply attaching 3 750 ohm resistors to the board to attenuate the brightness, and that's them in the upper left up there, to installing entirely new prefabricated or homemade RGB bypass circuits. I did this one on Wednesday afternoon, I think. But this little board sits on the back of the new style NES board, and it connects to the multi-out port that eventually goes outside of the machine. So what's going on here? The one-chip 03 and new style SNES, which are the final and ostensibly superior versions of the console, have added wrinkles to them. On a one-chip 03, a handful of tiny components costing less than $1 in total have been removed to save money. So the console has RGB, but not a dedicated C-Sync signal. If you see the Q1 there on the lower right-hand side, there's a sort of black chip in the middle, and the 4 chips around it, plus that, are the pieces that you have to put back into a one-chip 03 in order to get C-Sync. They cost about $1, and there's a guy who'll sell them to you in a little bag. So accordingly, once you've done this, you can either use a SCART cable that sends sync over Luma or restore the components to get back C-Sync. The smaller new style Super NES has the same chip, but RGB and S-Video components have been omitted. If you bother to restore them, you get the best possible signal quality of any Super Famicom or SNES. Now, the only way to identify a one-chip is to open the case and look at the motherboard. This is the motherboard of the one that I just showed you with the restored components from the front. And the only way to ensure C-Sync and or S-Video are present is to check what's connected to pin 3 in the multi-out port. Now, this is where modding begins to function like other cultural techniques as a form of self-legitimation and authentication, because it requires doing something that most of the millions of console owners have never done. Bypassing Nintendo's proprietary security screws, then removing the RF shielding over the board, then removing the board from the case entirely to examine the backside. Making a tool out of a partially melted Bic crystal pen or a Dremeled flathead screwdriver is always possible, but smacks of a particularly muscular version of nerd machismo. The pragmatic approach is to order the tool off of Amazon for about $2. Once you know what you actually have, there are two options. You can perform the mod yourself or find someone who can. Neither option is easy, because locating a modder, getting them to talk to you, and then agreeing to provide service can be tricky. Without commissioning work from and corresponding with modders, I don't think I ever would have gotten to the point of either performing mods myself or understanding how the chains of technical operation end up functioning as a kind of distinction-producing machine that generates modes of subjectivation, media objects for circulation, and the expert discourse that powers interpretive communities. So this is an SNES one-chip 02, sort of. After cracking it open to verify the motherboard stamp, and again, down the bottom you can see it says SNS CPU one-chip 02, I reassembled it, and then I connected it to this. This is the standard analog testing station in the depot, which consists of a Sony PVM14N6U monitor, an Extron 201 RXI, which is the little box on top, it's a video processor, and either an R-CADE forged sync strike or an RGC SCART Extron dongle with built-in sync stripping circuit. We're a long way from Super Mario here. Via two shielded SCART cables, one with C-Sync and one with sync over Luma. Now the C-Sync cable should have produced an image, but it didn't. Sync over Luma worked fine. Online community discourse on the subject was adamant that the one-chip 02 should have C-Sync capability. So I asked Leon Kurluk, who's a Toronto modder of some repute, and he'd done some work for us in the past, to take a look at it. And he verified that the C-Sync circuitry was simply missing, which essentially makes it a one-chip 03. After a lot of digging, I found a single post in a subreddit from someone else with the same issue, but this flies in the face of conventional wisdom on the subject and is a significant verification of someone else's findings. So this is what Leon did. He installed an RGB amp from a modder who goes by the handle Bordy4938, usually just Bordy, to restore the circuit. And it produces this amazing image now. But this is where I begin to have more to say than I can communicate in the time allotted. For one thing, once you're face to face with the technological real, Ernstian media archaeology hits a hard wall. The only way to make sense out of why different choices occur in signal processing is via their cultural articulations, hence the growing interest in cultural technique theory. So let me give you some examples. For one thing, you can often tell who modded an SNES by the color of the solder mask on the circuit board. So Voltar's chips are blue, Retrofix's chips are red, Video Game Perfection's chips are green, and Bordy's are purple. And the purple is particularly important because what that indicates is that they've been sourced from a company called Oshpark, which is a fabricator of bare circuit boards in the open hardware community. So modders will design boards, they upload them to Oshpark, then anybody can go order the boards, source the components, and then do their own assembly with varying degrees of sophistication. I can now build a basic RGB amp on a generic board sourced from China, but it's not as pretty as this. Configuration options on boards also vary according to taste as well as functionality. The Depot has a new style Super NES with what I first thought was the same board as the One-Chip 02 until I realized that among its other options, it also has C and Y pads to restore S-video if it pleases you to do so. So over in the far corner there, you can see on the right, or in the middle is R, G, B, and C sync for red, green, blue, and composite sync. And over on the far side, there's a C and a Y. So if you connect two wires to the C and the Y, you can actually use an S-video port, but I don't think we even own an S-video. I have a lot of cables. I don't think we even own an S-video cable for an SNES. So even something as innocuous as connecting a solder strap on an RGB amp to activate a low-pass filter is linked to cultural protocols. So what a low-pass filter is exactly what the name would apply. It allows low-frequency signals to go through and it cuts out high-frequency signals. High-frequency signals are a source of noise in many cases, so you don't want them going through. It makes your image slightly softer, but also less noisy. So the original SNES has a low-pass filter on. Without it, there will be noise in the channel. Until recently, most commercial SCART cables have come with an LPF built in because, yeah, here you can see on board, this is a Voltar board, and right in the middle it says LPF on or off. If you connect those two pieces of solder, then the LPF is on. So the thing is, most of the processing units like the XRGB Mini and the OSSC can have this on or off. It doesn't matter if it's there if you're using a professional video monitor because the noise is too high frequency for the monitor. Nevertheless, and this is what interests me, what Leon told me is, he says, quote, off is what some of the cool kids want because you should ideally only have one low-pass filter in your chain in order to prevent image softening. And if you have a lot of consoles connected through this thing, this is a G-SCART SW. This is a very esoteric switching device which has an LPF built in. I don't even have one of these things. It would be redundant. But again, the assumption is that your consumption of this kind of equipment is at such a level that you might actually not want that switch on. So on the most base material level, the operation of soldering itself bears considerable cultural freight. There are dozens of videos on YouTube and countless social media posts about soldering style, which often focus on sneering at the poorer examples. The only faux pas worse than poor soldering is using hot melt glue as a material support for the connections. This was a practice that was in vogue a few years ago and now receives nothing but scorn, largely due to the oddly obsessive videos of Lord Voltar, a major modder and mod kit vendor. So these two guys are major fixtures in the RGB community. The guy on top is Lord Voltar. He's the one who makes the blue boards. He also does modding as a service. The guy underneath is RGB Bob, who's like, he's like the major, he's like the Rachel Ray of RGB, like he popularizes it. This is an odd video because what happens in this is he takes his old mods and he shows them to Voltar, and Voltar tells him why they're not good soldering. So again, it's a very, very intense but weird little world. So what have I learned from all of this? RGB amp mods are a textbook example of what Michel Serres calls a third in the parasite, which is a major touchstone for both media archaeology and actor network theory. A third doesn't belong to either the perceiving subject or the perceived object. It enables perception by removing itself from perception. Most people never knew that mods were possible. Even today, the number of people that have performed them remains tiny. Those that pay for them rarely open modded consoles, even if they have the tools, could not identify the mods if they could find them, or understand what the mod is actually doing. Few experienced modders can even accurately measure the changes that they have made. This kind of modding, I think, is important because it provides a glimpse of the material production of nostalgia as a pure simulacra. RGB modding provides access to capabilities that may have been present, or at least implicit, in the historical moment of the console's popularity, but was rarely, if ever, activated. What they do is make a console function in some new, specifically 21st century way that also, paradoxically, claims to be more true to the operation of the console than an unmodified unit. Now, for those of you that know this game, this is a ridiculous image. What this is this is Samus, of course, this is from Super Metroid, through an analog Super NT field programmable gate array hardware simulator at 1080p, taken through a fixed 80mm macro lens. The amount of detail in this is insane. What makes it a simulacra is that its referent is an image built from the perfectly square pixels of 21st century software-based emulation, or the crisp, heavily banded image of a professional video monitor, not the soft phosphor dots of a 1980s home CRT. The images that RGB modding produces, then, are two perfect versions of a past that frankly never existed in that form. We can and should be as precise as possible about the identification and measuring of subsemantic signal transmission. And I'd argue that we haven't done this enough because, as Jeffrey Winthrop Young points out, structures and entities tend to render invisible the constitutive technical operations they arise from. We need to be able to tell forgotten and ignored machinic histories. But what cultural technique theory also tells us is that the meaning isn't in the signal or any other sign or object. It's in its articulations, which are always contingent. Measurement will always be measurement for some interpretive community in the context of metrics established by some authority. There are power relations at work here, and we need to understand them better. Thanks.
So emulation has historically been an attractive alternative to using video game hardware, not only owing to its ostensible costlessness, but also due to its accessibility, ease of use, facilitation of gameplay modification, and its role in software preservation. Yet in contextualizing the use of emulators in the preservationist context of museums, Rayford Ginns argues that despite the opinions of gaming communities, emulation does not purport to be the original game it simulates. And he articulates his doubts that emulation can reactivate the object reproduced. This viewpoint is pervasive and such that much scholarship on video games neglects to treat emulators and modified consoles as worthy platforms that contribute to our account of a console as both an artifact and as a cultural object. This resistance to considering emulators as legitimate platforms in the narrative of video game technologies appears to stem from the anxiety that it cannot reproduce the original. Yet consoles and games are themselves mechanically reproduced, often in numbers that exceed thousands, and so they arguably fail to command any erratic authority, at least in the sense that Walter Benjamin describes. So I therefore question the very notion of an original console and argue that our perspective is limited when we attempt to divide these objects into originals and derivations. So what we have instead is a networked assemblage of objects that not only respond to cultural tendencies, but actively help shape them. So this paper is a fragment of the master's research project I'm currently pursuing, which focuses on the Game Boy Advance and the various platforms and emulators that have been developed to play its games. So these include, on the one hand, the sanctioned Game Boy Player add-on for GameCube, the backwards compatible DS Lite, and the Virtual Console for Wii and Wii U. And then on the other hand, the unsanctioned emulators for Android, Windows, Raspberry Pi, a soft-modded Nintendo Wii, as well as the built-to-order retro-modding GBA recently purchased by the Residual Media Depot, and I'll talk about that one in more detail later. Writing on the place of technology in Bourdieu's social theory, Jonathan Stern suggests that although the meanings and functions of technologies are socially shaped, their roles are co-created with the makers and users of said technologies. These roles change depending on any given community and cultural moment, and Stern thus encourages an epistemological break with the common sense of technology in order to conceive of these roles. In the case of a video game, I suggest that performing this break requires looking beyond the narrative of the game to see the materiality of the platform, its agency, and its position within a wider network of afterlives. And of course, I see these afterlives not just as decrepitude or retreat into archival storage, but in terms of backwards compatibility of future consoles, digital re-releases, emulators, and of course, modified consoles. So by expanding our scope to survey the network of afterlife objects that form our conceptualization of the Game Boy Advance, we can think through more clearly issues of embodied experience, organized movement, and social organization. So video game technologies are necessarily embodied, demanding a mutual relationship between the body of the platform and the body of its user in order to access the internal workings of the game. Cultural technique theory posits that media are not passive objects waiting for human interventions, but rather that they supply their own rules of engagement on a material level. The technical specifications of the Game Boy Advance suggest an idealized body upon which affordances and constraints are based. So a portable console needs to be light enough to hold for a significant amount of time, small enough to transport and play on the go. Its chassis must be durable and ergonomic, and it must also meet and often exceed consumers' aesthetic expectations. Unlike its predecessors, the Game Boy Advance is horizontally oriented with a beveled shell, which makes holding it much more comfortable than holding the vertical predecessors, since hands are less cramped together, returning to the layout of something like an NES controller. Measuring approximately 5.7 by 1 by 3.2 inches and weighing around 201 grams with 2 AA batteries, the 2001 Game Boy Advance was an immensely portable console for its time. But although the last 17 years have seen our mobile devices become increasingly slim, leading us to expect games that can easily slip into our pockets, this wasn't necessarily the case in 2001, and so the portability of the GBA was still relatively new and exciting. But the cost of carrying the entire platform from processor to battery in one small object is the sacrifice in processing power and display quality. These concessions in computational capacity are only really visible to the human gamer through the textures and artifacts of the games designed and developed for the console. And so we see these objects communicate their constraints through audiovisual channels. One of my favorite examples of these constraints comes from the Fire Emblem series. So in its installments for Game Boy Advance, characters have very detailed portraits, which are the ones at the top. And those appear in menus and during conversations between chapters. But the layout of the maps, which you see here, are so small, and the icons would have to be so small that these detailed portraits can't actually be supported. And so the developers had to design secondary, very simplified portraits for use within levels, and these are kind of like ridiculously simplistic and kind of goofy looking. And so even though they're rather innocuous while you're playing the game, they really point to the broader concessions necessary for the body of the platform to achieve portability. So bodies, whether human and object, converge to highlight these operative chains that exist. So emulation troubles the bodies involved and directs attention to previously invisible processes and infrastructures. The release of the Game Boy Player 2 years after the Game Boy Advance gestures to the constraints of a portable console and the constraints that are placed on its consumers. So the player uses near identical hardware as the Game Boy Advance, but it connects through the high-speed parallel port that exists at the bottom of the GameCube. What this does is use the GameCube as a conduit to output visual and audio signals to a television and outsource the power supply to an electrical outlet. Placed side by side, the two technologies highlight the affordances of each, portability at the cost of accessibility. Despite the kitschy purple border that frames gameplay on the player, the ability to access the GBA game in almost any light environment and to see the screen from a healthy distance permits a player to experience a game they might not otherwise be able to for reasons of the screen being too small or the buttons too hard to press, etc. Similarly, the decision to release the first two models of the Nintendo DS as a backwards compatible handheld allows GBA games to continue to be portable even as they're now displayed on a backlit screen. At the same time, we also have consumers' interventions into these technologies through emulation and console modification. So the MyBoy emulator on Android permits the games to be played with one hand on a device that comes with us nearly everywhere, similar to how the Visual Boy Advance emulator for PC runs off a device more people already have and use daily as opposed to proprietary hardware intended for limited non-gaming use. As we saw yesterday as well, a Wii can run the Visual Boy Advance GX emulator to play GBA games on a television with less hardware than a GameCube and also removing the distracting purple frame. So emulators are reliable, customizable, and offer additional functionality, such as the ability to alter display settings, change controller configurations, and save and load save states. A comparative approach to the afterlives of the Game Boy Advance offers insight into the complex interactions between platform, game, and embodied player. As part of this project, I've compiled a table of specs for each platform to collect and organize data on the afterlives and their limitations on both the games and the bodies of the people playing them, the infrastructure they make visible, and the aspects of gameplay they make invisible through familiarity. The range in cost, battery life, and retail availability, among other factors, speaks to the various constraints each new platform addresses. And these trends, in turn, raise questions about geography, temporality, and cultural context. Yet we might wonder why there's a continued and continuously renewed interest in the GBA when nearly 2 decades of hardware and software outperform it. So, like, the Game Boy Advance has one of the largest homebrew communities thanks in large part to the accessibility of its emulators, but I also want to argue for the impetus of nostalgia based on the contingent imprint of the console on particular generations of gamers. So the Residual Media Depot at Concordia University recently acquired this beautiful thing, which is a retrofitted Game Boy Advance from Montreal-based company Retro Modding. So it sports an AGS 101 backlit display, digital brightness control, the GB-Amp V3 audio amplifier, a glass lens, and a 14-hour USB rechargeable lithium-ion battery pack, all contained within a translucent orange aftermarket shell. So this handheld effectively captures the feeling of a 2018 Game Boy Advance. So none of this would have been found in a 2001 GBA, but you can get it for, I think, around 500 Canadian, like 300 something US, not really sure what the conversion is. So all this can be yours. So a few weeks ago, we met Olivier, who runs Retro Modding, and he explained to us that his foray into modding was motivated by childhood recollections of playing with Nintendo's early handhelds, explicitly connecting the desire to mod consoles with a nostalgic impulse. Svetlana Boym defines nostalgia as a longing for a home that no longer exists or has never existed, which can never be regained, only perpetually replaced. She argues that nostalgia as a condition necessitates an aesthetic cure, which has long been commercialized, and identifies 2 variants of nostalgia, the restorative and the reflective. The former ignores or effaces signs of historical time or imperfections to emphasize the familiar. The latter recognizes pastness and finitude. As she notes, the focus of reflective nostalgia is not on the recovery of what is perceived to be an absolute truth, but on the meditation on history and the passage of time. The retro-modded GBA does this work in recognizing pastness, isolating the constraints of the 2001 GBA and making alterations to improve the handheld's appeal and accessibility. Gamers can enjoy the physical and embodied experiences of interacting with its chassis while also benefiting from the affordances expected of a gaming device in 2018, backlit screens, chargeable batteries, etc. But I also want to argue that the embodied experience of playing on the modded GBA is not necessarily any more artificial than playing the so-called original from 2001 in a contemporary setting, since even perfect reproduction cannot reproduce you as the gamer, or the 11-year-old's hands that originally picked up the console in 2001. Picking up that same console today cannot strip away the distorting or intervening experiences one would have to unsee in order to access the original experience. So the very fact that our cultural expectations dictate that our handhelds are rechargeable and backlit mediates our return to the 2001 Game Boy Advance, just as our experience watching a recent CGI film mediates our experience of watching CGI from 20 years previously. So modding as a cultural technique acknowledges the passage of time and puts into conversation the material objects with all its attending processes and the body of the player encountering its agency and effective potential. Undertaking a study of this liminality, this meeting of media and human, allows us to conceive of the operations that reproduce or reflect social distinctions. In addition to the hardware alterations to the GBA, the Residual Media Depot also owns a flash cart onto which were added Game Boy, Game Boy Color, Game Boy Advance, and Nintendo Entertainment System BIOS and configuration files. This flash cart fits into the GBA game slot and allows users to load games from those 4 platforms. Such a device makes an intervention into the proprietary model of processors protected from end users. So in What is Media Archaeology, UC Parika argues for the necessity of considering the important political economic implications of how the fact that power is now circulated through software to hardware is inseparable from the proprietary industries that produce these platforms. So Nintendo controls our access to the machine not only through the graphical user interfaces, but also through their very proprietary processes. So the flash cart that allows this retro modding Game Boy Advance to play any of the hundreds of games ever released for Game Boy, Game Boy Color, Game Boy Advance, and NES, the last of which wasn't even included in the backwards compatibility of the original console, resists the governance of protected software. And this resistance is a product of a relational network of people who figure out the pieces to make these processes work and then share them with a broader community. So modding communities support and make use of the right to tinker to exploit proprietary software and effectively expose just how little the end user typically sees. It also makes way for new communities to engage with an object in a way Nintendo did not intend or predict. So yesterday, for instance, we, as a community, soft-modded a handful of Wiis, and we spoke about some of the ideological reasons for doing so. So in GBA communities, let's say, adding the ability to overclock the console allows speedrunners to practice completing games in unthinkably short amounts of time. And these playthroughs are then recorded and broadcast online, and records are kept, engendering a sense of community based on these activities. The ability to alter and reload game files into an emulator also has the potential for enthusiasts to translate and render accessible games from, let's say, Japan that were never released in North America, or else to translate games into their own language to share with their communities. So these modded handhelds take an old device and defamiliarize it in order to make it feel new again. And it's from this ostensible newness that the aesthetic desire for nostalgia finds satisfaction. So the increasing obsolescence of the 2001 Game Boy Advance, when placed against more ergonomic, cost-efficient, accessible, or versatile alternatives, provides an occasion for thinking through materiality, infrastructure, embodiment, and nostalgic experience. Any mod of the Game Boy Advance necessarily speaks to some lacuna in functionality, accessibility, or aesthetics of the 2001 hardware or software. A comparative analysis between these platforms demonstrates how technology shifts incrementally to adapt to various social, cultural, and economic factors, allowing us to encounter a much larger network than is visible if we study the Game Boy Advance as an isolated object. Software and hardware emulation sanctioned through licensed products or otherwise thus allows us to obtain a fuller account of the game as both artifact and cultural object. So considering modding practices undertaken in interpretive communities helps us recognize that video games are not only structured by human practices, but that they in turn actively structure human practices.